All right, so we have just finished up with step 2 in our procedure to calculate out and figure out standard deviation. Now, remember that is this part right here. Our next step then is to sum all of our results from this. So let's go ahead and pull my calculator up here so that we can start to use it. So let's go ahead and get the calculator. Now, we're going to need to remember the number of zeros here that you have. So let's go ahead and this one's going to be 0.000133924, and I'm going to say plus. Now, to help me kind of keep track of these, I'm going to kind of put my cursor over here just to make sure that I know exactly where I'm at. So let's go ahead, plus 0.00009 backspace. Got to have 4 zeros in there, so 9604 plus. So make sure that you are paying attention to detail and getting all of the zeros that you need in. So 0.0003364 plus. So now we're here in this one. So that's going to be plus 0.00000064. So come on over here. I'm going to highlight this one, come back to my calculator and say plus 0.00000004. So again, as you sit here, yes, there is an easier way to do this, so we will talk about that. Right now, I just want you to kind of follow along and make sure that you understand what's going on as we sit here and kind of do these calculations. So, all right, so now my next one here is going to be plus 0.00000484. So come back so that I'm keeping myself informed of where I'm at. So 0.0001764 plus. So now I'm moving on to here. So that's going to be 0.00002704. So scroll down over here. So we're moving on to this one. Plus 0.00005184. So, and then I'm almost done here with my last one. So this is going to be plus 0.00008464, and we can say equals. So the sum of all of those are going to be 0.000061436 is the sum of all of those squared. All right. Now, I'm going to take that sum. So next step, and we're going to divide it by the population size. So let's go ahead and hit there, and we'll say divided by our population size, and this was 10. So minus the 1. So we got our n minus 1, so is going to be 9 equals. Now, here we're getting this scientific calculator out as far as this, and we're getting a value here of 6.826222, and it says e to the minus 5. So what does that really mean? Well, so if you really sit there and think about that, if we go e to the minus 5, so our standard deviation is going to kind of move back from one of those decimal points. All right, so as a reminder, so if we've got this 6.826222 repeating times 10 to the minus 5th, that is, let's write this down here. That really means we're going to move that decimal place over. So let's take that. We're going to go 5 places to the left here. So that's going to be 1. So 2, 3, 4, and 5. So, and we'll place the decimal place there. So we're moving that over. So your calculated summation here, when we sum all of those differences, is 0.0000682622. Your calculator up here just gave it to you in that scientific notation of 6.8262222 repeating times 10 to the minus 5th power. So just kind of reminding you of this type of scientific notation on a calculator. Now, so this number here is what we have to take and sum, or take the square root of, in order to actually find the actual value of our standard deviation. So if I take that, so you can kind of see here, it's the square root of that number, and we'll kind of go ahead and hit, and you see here that the standard deviation then becomes 0.008262. So let's go ahead and kind of write that down over here with our calculations out. So let me kind of come back in here. So 0.008262095510356. We'll go ahead and just write those all down. Now, remember in our original data set, so as far as that goes, we basically had all of these in terms of the data set in the 3-place decimal. So we're going to sit here and go in now and just kind of keep this to the 4th place decimal. So this actual standard deviation here will be 0.0083 to give us the rounded up version. So we basically have 8 thousandths and 3/10 standard deviation up here in our data set. So as far as the overall length of this. Now, as we take a look at this, so to be perfectly honest with you, at a 1.275 plus or minus 10 thousandths, if we're getting a data, a standard deviation of almost 8.5 thousandths here, that's an awful big standard deviation. So we would probably want to try to figure out some more controls on that. So as I was going back through and something didn't quite seem right to me, so this is one of the reasons why we really got to kind of make sure that we are doing what we need to in order to kind of make sure that everything is lining up and our numbers are correct. Now, so something didn't quite seem right with me on our standard deviation. So I've gone back through. Our mean was calculated correctly. I've gone back and redid all of these. Now notice when I added these up and summed these up the next time, this was what I got originally, and next time I've got this particular summation here. So, and going back and double checking it, that is indeed the correct sum of all these squared roots. So from there, at this point, as I divided by the different standard populations, we did come in, and our actual standard population, so our standard deviation here worked out to actually be 7 thousandths and a tenth, a little bit tighter than the 8 thousandths and 3/10. But so again, if you were following along and your numbers weren't adding up to mine, you were correct. So, and just another reason why it is important to kind of make sure as you're going through and doing these calculations that you are making sure that you're not missing anything, that you are keying in the correct key sequence, that you got the right type of trailing zeros or zeros between the decimal place and your actual numerical value. So make sure that you're going back through there and double checking on all those to get the correct answer. Your correct standard deviation here, as you take a look at this, is 0.007 thousandths and a tenth is the actual correct standard deviation. So if you got that, you did everything with your calculations correctly. If you didn't get that, go back through and double check and see what you did. Now, in a future video, we will come back in and we will use the TI-30XA calculator, and you'll see how the calculator makes a lot of this calculation a lot simpler.